Hi everybody, this is Dr. Hamid with your College Mathematics 120 class. Today we'll talk about section 5.3, which is about rational numbers. Okay, so in this section, our main focus will be on rational numbers. Okay, we will talk about the definition. Okay, we will define rational numbers. We will explain the structure of a rational number, and then we'll talk about different representations of rational numbers, how to write a rational number into a decimal form, into a mixed fraction, into improper fraction. Okay, and then we'll learn how to deal with the mixed numbers and improper fractions. We will talk about how to add, multiply, and divide rational numbers. And we will also learn the order of operation of rational numbers, and some applications and of rational numbers. Let's start with the introduction to the rational number. Simply speaking, a rational number, it's a number that can be written as a ratio of two integers. Okay, so if you have two integers and we form a division or a ratio, okay, so then as a result we will get a rational number. Okay, now a rational number we can also write it in decimal form. Now if it is really a rational number, then it will be either its decimal form will either terminate or it will just keep repeating. Okay, so a rational number written in decimal form is terminating or it's repeating, keeps on going. Okay, I will explain it later on. Now let's talk about the mathematical structure and mathematical definition of a rational number. The set of rational numbers is the set of all numbers which can be expressed in the form a over b, where a and b are integers, okay, and the denominator b is not equal to 0. Okay, the a here is called the numerator, the top part. Okay, the b here is called the denominator, which is the bottom part here, which has to be non-zero. We remember we cannot divide anything by 0. Okay, when we get 0 in the denominator, we are in trouble. So b has to be non-zero. And the few examples of rational numbers are, any ratio of two numbers, 1 over 4, 1 over 2, 3 over 5. Okay, 5, 0. You can think of this as 5 over 1. Okay, so rational number, ratio of two numbers. Improper, but still a rational number. Now this is something we deal with every day, very often in this math course or in other math courses. Okay, where a fraction is given to us, a rational number is given to us, which is a ratio. Okay, and we have to reduce it to bring it down to the lowest terms. Okay, now if a over b is a rational number, okay, which is where a is some integer, b is some integer, you can think of it as 1 over 2, 5 over 4, anything. Okay, if a over b is some rational number or a fraction there, okay, and suppose we c is any number, okay, other than 0, which is non-zero. C is anything which is non-zero. Okay, now this is the property which we will use to reduce a rational number. Okay, then this property says that if you multiply and divide the top and the bottom with the c, it does not change anything. Okay, let me bring it down in simple words. If you have a fraction and you take a number which is other than 0 and you multiply it with the top and the bottom, things will not change. The fraction will remain the change. Its behavior will remain unchanged. Okay, as long as you do the same thing in the numerator and same thing in the denominator. Okay, so precisely speaking, rational numbers a over b originally we started with, and the one we got after multiplication, ac over bc, are called equivalent fractions. Okay, equivalent fraction. They will produce the, some might have the lower numbers, less work. Some might have higher numbers, more work, but they are equivalent. They will eventually produce the same kind of result. Okay, now how do we reduce a rational number to lowest terms? To reduce a rational number to the lowest terms, we will use a concept which we learned in 5.2 and 5.1. We will divide both numerator and denominator by their greatest common divisor. Okay, we will write it in its prime factorization, then pick the common factors, multiply them, and that will give us the greatest common divisor. Okay, so let's look at an example here. A rational number is given to you, 130 over 455. Our goal is reduce the given rational number to the one with the lowest terms. As I said earlier, okay, it all begins with the greatest common divisor. Okay. Now let's find the greatest common divisor of the numerator and denominator. Both are numbers. Okay. So 130 and 455. If you remember from the previous sections, to find the greatest common divisor, we have to write the prime factorization of both. Okay. Prime factorization of 130 is this. Prime factorization of 455 is this. Okay. Write it down. So 130 is 2 times 5 times 13. 455 is 5 times 7 times 13. Look for the common factors. So we have 5 and 13 as common. So these two things are common. I wanted to circle 5 and I wanted to circle 13. I don't know how it went away. Let me do this, correct it a little bit. Okay, sorry about that. Okay, so now 5 is common and 13 is common. Okay, now to find the greatest common divisor, we must multiply the common factors. Okay, so multiply 5 and 13. Your greatest common divisor is 65. Okay, that was just piece of the puzzle. We have to go back and write it into the lowest order terms. Okay, moving on, our fraction is given to us, which is 130 over 455. Divide both numerator and denominator by 65, the greatest common divisor you just got. Okay, so that will bring it down to the lowest, which cannot be further simplified. So divide the top. Okay, I symbolically wrote so that you can see. Divide top by 65, divide bottom by 65, and your final answer comes out to be 2 over 7. Okay, you are done here. This is the lowest. You cannot go any further. Okay, both are prime, no common factors. Now there's another way, okay, alternative way of finding this one. Okay, again it is based upon the prime factorization, but you might like that one. So let me put it up there here. So write down the prime factorizations of 130, which is 2 times 5 times 13. Write down the factorization of 455, which is 5 times 7 times 13. Okay, now think of it as the multiplications. What can we cancel here? We can cancel this 5 with this 5, correct? We can cancel this 13 with this 13, right? And what is left? 2 and 7, and we go right there what we had earlier. Okay, so we can cancel 5 with 5, 13 with 13, and 2 over 7 remains. That is our lowest order terms. Okay, you can do either way. You can use the greatest common divisor, or you can do this way, or you are free to do any way you learned in high school or wherever. Okay, or in some other class. These are two methods which I'm going to talk about. So let's summarize. As I said earlier, there is no common divisors of 2 and 7 anymore. Okay, so we stop right there. So the rational number 2 over 7 is in its lowest terms. There are problems like that on your homeworks. Make sure you understand it. Okay, now let's talk about mixed numbers and improper fractions. Okay, now a mixed number, it consists of a sum of an integer plus a rational number. So you will have a number, okay, sitting on the side plus a fraction. Okay, so and precisely speaking, a mixed number consists of a sum of an integer and a rational number expressed without without explicit use of an addition sign. What I mean here is this one here. Okay, this is a mixed number, 4 and plus 6 over 7. Okay, now it's a mixed number. What it basically means is that 4 added to 6 over 7, but we don't write the addition explicitly here. Okay, let me write it down here, put it down here. So we have two numbers here. One is 4, okay, the whole number, and one is 6 over 7. So this basically means that 4 plus 6 over 7. Okay, that's what basically you will do if you want to write it into a decimal form. Okay, so 4 plus 6 over 7. So 4 is added to the rational number, but conventionally speaking, we do not write this plus sign here. So we will write it like this one. Okay, that's called a mixed number. Now improper fraction, I'm pretty sure you all know that improper fraction is, it's also called top heavy, when the numerator is a bigger number, okay, than the denominator. So examples of improper fractions are 5 over 2, 15 over 8, anything where your numerator is bigger than the denominator. Okay, so that will be an improper fraction. We'll do a few more things with the mixed numbers and improper fractions, but I want you to understand it on this slide here. Okay. Okay, let's move on. Now, let's convert, these things can go back and forth, as you might have guessed, okay? So now we'll talk about how to convert a mixed number to an improper fraction. And then we'll talk about the other way around as well, okay? So suppose mixed number is given to you and we have to convert it into an improper fraction. So let's look at an example here. A mixed number is given to us 3 and 4 over 5. Okay, so this is basically 3 plus 4 over 5. And we have to convert it into an improper fraction. So now our new number, okay, which will be an improper fraction, it will have a new numerator. Okay, it will have a new numerator, but the denominator will be same. Denominator will still be 5 here. Okay, now the question is, how do we get this new numerator? What we will do here is we will multiply 3 with 5 and add 4 to it. That will be our new numerator. Okay, let me write it down here. Multiply the denominator of the rational number with the integer, that's written on the side here, with the integer, and add the numerator to this product. Okay, mathematically speaking, if you have this one here, you will take the denominator, okay, right there, multiply it with the integer, which is 3 there, okay, and then add the top, the numerator, the given numerator. Okay, so if you do all this arithmetics here, okay, you will get 3 times 5 plus 4, 19. As I said earlier, we will have a new numerator and the numerator will be 19, okay, but the denominator will be same. Okay, denominator will be same. So use this 19 as your new numerator, okay, and the denominator will be same, and that will give us our desired improper fraction, with which will have a top heavy. Okay, so this is our desired answer. Okay, understand it. Let me go over it again. So if you want to convert a mixed fraction to improper fraction, multiply this integer with the denominator and add the top. Okay, that will be your new numerator, and the denominator will be same as in the mixed fraction, which is 5 here. Okay, so that will give you your answer. Now let's, as I said earlier, let's go back from improper fraction to a mixed number. Okay, the other way around, as compared to the previous slide. So if an improper fraction is given to you, remember that if it's an improper fraction, it's top heavy. Okay, the top number is bigger than the denominator. So take the, divide the numerator by the denominator. Okay, and you will need quotient and remainder, so keep those in hand. Okay, and then we will use this formula here to write it into a mixed number. So we will have quotient on the side, it will play the role of our integer, and then remainder on the numerator and original denominator in the denominator. Okay, so suppose we want to convert 42 over 5 to a mixed number. Look at it, it's a top heavy. Okay, so this is an improper fraction. What you will do, you will take this 45, okay, 42, and divide by 5 using long division. Okay, so I hope I don't have to explain the long division. You know how it is. Okay, so it's 42 here. 5 times 8 is 40, the closest, and then you take the difference here. Okay, as I said, we have to keep note down the quotient and the remainder. So you need a quotient, the answer, and the remainder, what is over here, and then quotient goes here, the remainder goes on the top, and the original denominator, which is 5 here, or what are you dividing with, goes in the denominator. That is your mixed fraction. Okay, mixed number here. So 42 over 5, we can write it into 8 plus 2 over 5, or 8 2/5. Okay, that is how you convert improper fraction to a mixed number. Now this thing is sort of easy, how to go from rational to decimals and decimals to rationals, a ratio of the two. Okay, so let's look at first how to convert rational numbers into a decimal. Okay, any rational number, we can express it in the decimal form by dividing the denominator into the numerator. Okay, take the numerator, divide it by the denominator. That's it. Okay, you can do it by hand, you can do it using calculator. Okay, any way you feel comfortable. Okay, so for example, if you want to convert 5 over 8, which is a rational number, okay, and let's say 7 over 11 into decimals, what you will do, you will take 5 divided by 8. Okay, you can do it, as I said, if you can do it by hand, or you can do it using calculator. Okay, so if you I'm just putting up the long division ways so that it will refresh your memories. But you can also, as I said, you can also use calculator directly. Okay, so put 5 in there and then divide by 8. Since the numerator is smaller, smaller thing you're dividing by the bigger thing, you put decimal there, so on so on. Okay, and notice that after few division steps, we get remainder 0. There's nothing left. Okay, so this kind of a rational number is terminating. Okay, so we have a terminating decimal number. Now this one will be a repeating one. You will see that. Okay, so let's look at the other one. Now this time we divide 7 by 11. Okay, and you see that we keep on going and that answer keeps repeating. We get 63, 63, 63, 63. So 0 0.663, 63, 63, 63, 63 keeps on going. So this is sort of a repeating. This is terminating. This is repeating. Okay, so after the decimal, 63 keeps repeating. This is called a repeating decimal situation. Okay, going back to the previous slides, first or second slide, I talked about that one. Okay, so if you want to write rational number and like this one, okay, so we will have it will goes like 7 over 11 is basically 0.636363. Okay, I don't know why I don't have it, but we normally put a bar on whatever repeats. Okay, so if you have a small line on 63, it will be that will mean 0.63 repeats. It keeps on going. Okay, I think I have a slide on that later on. Now how do you go backwards? Okay, so expressing decimal as a quotient of two integers. The previous one was easy. You can just simply use a calculator and you will have a decimal representation. Now if you have a decimal and you want to go back to integers, it might require a little bit of work. Little bit, not that hard, little bit of work. Okay, now suppose you have a terminating decimal. Okay, and we can express it with the denominators of 10, 100, 1000, 10,000 and so on, based upon where the decimal is located. Okay, so what I mean by that is, look at this chart here. If your decimal is at the 10th location, you will divide it by 100. Okay, you will put 100 in the denominator. If it is the 100th position, you will put it 100 down here. Okay, if it is a thousandths, you will put 1 and 3 zeros afterwards. Okay, you will use this table to convert decimals into quotients. So let me put an example here that will make things easier. Suppose you want to convert 0.7 into a rational number, into a ratio of two integers. So what you will do? So where is the decimal? Decimal is at the 10th position here. Okay, so this will go 7 over 10. I'm using that table again. Okay, now look at this one here, B part. So where is the decimal located? Decimal is at the 100th position, so it will be over 100. So this will be 49 over 100. Okay, and this one is the decimal is at the 1000th position, so it will be 48 over 1000. Okay, you understand it? Let me look at it here again. So this is 0.7. If you want to convert it into a ratio or the rational number, okay, it will be 7 over 10. And wherever you can, you will reduce it down. Okay, you will reduce it to lowest terms. Here we cannot, so just leave it like that. Similarly, 0.49 will be 49 over 100. Nothing we can do again. Okay, we cannot simplify it down. And here we have 48 over 1000, as I said earlier. Okay, this we can go further. Before we go into that one, let me tell you another trick here. Trick is, okay, let me go back. Now wherever you see point, okay, in place of point, put 1 in the denominator, and as many as integers you have on the right of the decimal, put that many zeros. Okay, here look at that. Here for point we have 1. For every digit on the right of that, we put 0 there. Okay, similarly for decimal we put 1. As many digits we have here, we put zeros for that. Okay, for decimal we put 1 and we have 3 digits there, so 3 zeros there. Understand what I mean? So either way you can remember. Now going back, I said we will reduce this 48 over 1000 into lowest terms. Okay, so we can reduce it by, if you divide both top and bottom by 8, so you will reduce it to 6 over 125. Again, going back to previous slides, you can practice it. I just omitted the details here. So this we cannot go any further. So this is your lowest order terms of this decimal representation. Okay, I hope it helps. Um, Now this is little tricky. Okay, this is might be new for some of you, and it requires little bit of thinking, little bit of work. Okay, suppose a decimal form is given to us which is repeating, okay, which keeps on going and it repeats itself. For example, as I mentioned earlier, 6 has a line on it. That means 6 keeps repeating and it never ends. It goes all the way to infinity. How do we represent this into a number ratio of two integers? Okay, so what we do is, to do that, we will call the given number, which is 0.666666 so on, we will call it n or anything, x or whatever you want. Okay, we call it n here. Now if there is one repeating digit, okay, as it is this one here is 66666, okay, is one digit. If it is a one repeating digit, multiply both sides of this equation by 10. If there are two repeating digits, okay, like in our previous example we had 6, suppose we had 63636363, okay, then we'll multiply it by 100. Okay, so now in this case, since our one digit is repeating, we'll multiply the whole equation by 10, like this one here. Okay, so like this. So n was given to us, multiply both sides by 10. Okay, now this is 10, and when you multiply 10 by 0.666, it will just be 6.6666. okay, as I mentioned earlier, if you two digits repeat, you multiply by 100 right there. If three digits repeat, you multiply by 1000, and so on, so on. Okay, you know where it is going. Now this is your new equation. Okay, and now what you do is you take 1 and take 2. Okay, subtract 1 from 2. This is 1, I labeled it as this 1 here. This is 2, so subtract that both of them from each other. Okay, and you will get, this is the second, this is the first. If you subtract it, you will get 9n from the left hand side. Okay, and here this 0.666 minus 0.666 is 0, so basically you get 6 there. Okay, now this is our n. Okay, that's what we were looking for. So divide both sides by n, by 9 here. So you will have n is equal to 6 over 9, which we can reduce to lowest terms. It gives us 2 over 3. Okay, so the integer ratio representation of 0.66666 is 2 over 3. Okay, as I said earlier, it is little tricky. Take a moment and make sure you understand each step here. Okay, the number of digits repeating, okay, first call it something, okay, then the number of digits repeating, you multiply that with that, and then you divide, subtract and divide, and you will get this answer. Okay, now let's move on to some easy stuff here. Suppose you want to multiply two rational numbers. It's as easy as it seems. You will multiply numerator with the numerator, denominator with the denominator. Okay, so if you have two numbers, symbolically speaking, a over b, c over d, if you want to multiply them, it will be a times c, b times d, and then you bring it down to the lowest terms. Okay, look at this example here. Suppose you want to multiply minus 2 over 3 times minus 9 over 4. Okay, so first of all, minus times minus will be plus. Okay, minus times minus will be plus here, and then you multiply top with the top. 2 times 9, which will be 18, 3 times 4, which will be 12, and then you bring it down to lowest terms, as I said earlier. Okay, so write it in the prime factorization or find the greatest common divisor, divide both top and bottom, and you get 3 over 2 as your answer, which you get after multiplying two rational numbers. Okay, now let's talk about dividing two rational numbers. Okay, division is same as multiplication. Okay, we just take the reciprocal of the second one. Okay, just take the reciprocal of the second one. What I mean by here is that, suppose you have rational numbers a over b and c over d, and you want to multiply, divide a over b by c over d. Okay, so what do? Whatever the number comes second, remember that we can convert division into multiplication if you flip the second fraction here. So first it was c over d, now it is d over c, and then you just do the multiplication as we did in the previous slide. Let's look at this example here. Okay, suppose you want to divide 3 over 5 by 7 over 11. So what do? you convert it into a multiplication and flip this second fraction. So it will be 3 over 5 times 11 over 7. Okay, instead of 7 over 11, 11 over 7. Then you multiply the tops and multiply the bottoms. And can you go any further? You cannot reduce it any further. That's your final answer. Okay, easy. I'm sure you have seen this before. Okay, now adding and subtracting rational numbers. Okay, we can have two kind of situations. First situation is the two fractions we are adding, they have the same denominator, identical denominator. That's an easy case. Okay, so the sum and difference of two rational numbers with same denominator is the sum or difference of their numerators over the same common denominator. Okay, for example, if you are adding a over b plus c over b, okay, it's a same denominator. Just put it that and add the tops or subtract the tops. Okay, whatever your question demands. For example, if you are adding 3 over 7 plus 2 over 7, okay, since it's the same denominator, it will make our life a lot easier. Just put the same common denominator here and add the tops. That's your answer. Okay. Similarly, if you want to subtract, now this is 11 over 12 minus 5 over 12, same denominator, use the same denominator, okay, and then subtract the tops, and that is your final answer right there. Okay, this was an easy case, as I said, identical denominators. Now things get little trickier, little harder if you have different denominators. Okay, so if you have unlike denominators, how you do it? You will have to make the denominator same. Simple as that. Okay, but as a part of the lecture, I will go over all the technical details how we make the denominator same. Now to add or subtract two rational numbers that have different denominators, we need LCM. Okay, we need least common multiple of the denominators to rewrite the rational number, which is called least common denominator. So what do you do then? Change each fraction to make their denominator same as the least common denominator, which is just LCM. Okay, then add or subtract the fractions as in that same denominator case. Okay, now remember, always remember, if going back to second or third slide, if you multiply the denominator by some number, you must multiply the numerator with the same number. If you don't do that, things go wrong. You have made a mistake. If you have a fraction, you do anything with either top or with the bottom, you have to do the same thing with the other half as well. Okay, now let's look at an example of how to add rational numbers with unlike denominators. Okay, suppose that you want to add or combine 3 over 4 plus 1 over 6. The denominators are not same. What you will do is you will look for the least common multiple, LCM. Okay, or or least common denominator, LCD we call it. Okay, so least common multiple of denominators is 12 of 4 and 6. Okay, you can do the prime factorization and you learned how to do it. You know how to do it. Okay, now remember that our ultimate goal is to make denominators same. Okay, so we will convert both denominators to 12. Okay, how do we do that? Now to make the denominator, okay, we will make the denominator of each fraction to 12 legally. Okay, that means no foul play. Okay, no forcing. If you do anything with the top, do the same thing with the bottom. So we'll multiply first the rational number by 3 over 3. That means you're multiplying top with the 3 and bottom with the 3. Second number, we need to make it 12, we need to multiply it with 2. So multiply top with the 2, bottom with the 2. Simplify it, so you will get 9 over 12 plus 2 over 12. Now it's the same denominator case. Okay, just put the same denominator down there and add the tops. That will give you 11 over 12. Okay, so that's it. That's how you will deal with when you have to add or combine or subtract fractions with the unlike denominators. Not that important, but let me go over it very quickly. It's density of rational numbers. It says that if R and T are two rational numbers such that T is bigger than R, then we will have something in between as well. Okay, let's call it S. Okay, then S will be between R and T there. Okay, so for example, if you want to find a rational number halfway between 1 over 2 and 3 over 4, we are looking for S here. Okay, so what you do here is first we add the two numbers, given numbers there, so it gives us 5 over 4, and then you divide this by 2, so that will give us the number exactly in the middle. Okay, so this is the number which goes in the middle there. Okay, so the number 5 over 8 is halfway between 1/2 and 3/4. Okay, so they're going back to our previous slide. This is 5 over 8 is between 1/2 and 3 over 4. So as I said, there is a number between two rational numbers. um, Not that important to this class at least. Okay, let's look at some applications of rational numbers where rational numbers are involved, or whatever we learned in this lecture involves. A very common application of rational numbers is involves when you have to adjust a recipe. Okay, suppose your original recipe, your grandma's recipe, that is for 4 people, and now you have to adjust it to for 6 people. Okay, if it is for 8 people, maybe we will double everything, but if it is for 6 people or 9 people, how do we do that? Okay, how do we adjust the contents or ingredients in the original recipe? The formula for that is this one here. So amount of ingredients needed. Okay, so how to change that? It will be desired serving divided by the recipe serving size times the ingredient amount in the recipe. Okay, so this is the formula you need to remember to adjust the recipe. And let me give you an example. Maybe it will help understand things. Suppose you are making cookies, chocolate chip cookies. Okay, and the recipe you have is for 5 dozen cookies, and it requires that for 5 dozen cookies, it requires 3/4 cup of a sugar. Okay, now this is 3/4 is needed for 5 dozen. Suppose you want to make 8 dozen cookies, how much sugar will you need? Okay, so this is very common problem here. This is the formula. Now our amount of sugar needed will be, it will be desired serving size. How many cookies we need? We need 8 dozen. So put 8 dozen there, and the original recipe has 5 dozen in it. So put 5 dozen there, and then times ingredient amount in the recipe. So in our original recipe, we needed 3 over 4 cups. So just put up there here. Okay. Now simplify this, rational numbers here. Okay, dozens cancels with dozens, so don't worry about that number here. Okay, so we will have 8 over 5 times 3 over 4. So the problem boils down to how to multiply rational numbers, and you know how to multiply rational numbers. You multiply numerator with the numerator, denominator with the denominator. Okay, so 3 times 8 is 24, 5 times 4 is 20. Simplify to the lowest terms, so you get 6 over 5. Okay, and since we are talking about cups of sugar, so it makes sense if you write it in the mixed fraction here. So 5 over 6 basically means 1 full cup and then 1/5 of a cup. Okay, so 1 plus 1 over 5, this much sugar you need. Okay, so for 5 dozen you needed 3/4 of a cup, but for 8 dozen you need 1 and 1/5 of a cup. Okay, so that's what you will need for your to have your original recipe working in the same delicious taste way. Okay, that's it, guys. Thank you very much for your time, and make sure you understand the stuff. Okay, make sure you try the homework problems, make sure you do the quiz. Okay, if you have any questions, let me know, contact me. I will try to help you as much as I can. Thank you.